All right, well, hello everybody. So we're going to go ahead and get started with the Algebra 2 semester exam review for Unit 2. So previously we worked on the Unit 1 review, which covered a lot of introductory to relations, um, functions, domain, and range. And now we're going to be going into Unit 2, which is going to kind of dive into more of that type of same material, but also including absolute values. It's going to be the big thing for this unit. Um, as we go through this, just a reminder that your semester exam will be on December 8th. It'll be a total of 21 multiple choice questions and 2 free responses. This is just a nice little dabble into some of the material that you will need in order to be successful on the multiple choice portions of the exam. Let's go ahead and get started. So for this question here, it's giving us an absolute value um, inequality, and it's asking us to graph this. So what we want to do first is let's go ahead and rewrite this out. We'll have -7 absolute value of x minus 6 is greater than -56. Now you'll recall our step 1 is we want to isolate our absolute value. So to isolate our absolute value, we want to get rid of this -7. The -7 and the absolute value are being multiplied, and the opposite operation of multiplication is division. So we're going to divide both sides here by -7. These simplify out, leaving us with the absolute value of x minus 6. And then -56 divided by -7 would be a positive 9. Oops, no, I'm sorry. Not positive 9, it would be a positive 8. Okay. Now, what happens with the inequality symbol here? Well, the inequality symbol is actually going to flip. Why is it flipping? Because we are dividing by a negative number. Because we're divided by a negative number, again, the sign flips. So now that we've isolated here, we're going to use the KISS method. Okay, where first time we'll just go ahead and solve this. We'll drop everything, solve it, we get our inequality, and then we'll apply the KISS method in just a bit. So for this first solve, we're going to have x minus 6 is less than 8. I want x by itself, so I'm going to add 6 to both sides. And I get x is less than 14. Let's go ahead and box this. For our KISS method, we start off with the same absolute value, x minus 6 is less than 8. But when we apply the KISS method here, we keep what we first start off with, what's inside the absolute value, which is the x minus 6. And then we switch the inequality symbol, which we're switching this here, and we're switching this 8 to a -8. And this is here what we're going to go ahead and solve. So to get x by itself, again, we add 6 to both sides. And we get x is greater than -8 plus 6 is -2. Okay? So when we graph this here, for our first graph, x is less than 14. We go to 14, we're going to have an open circle here, 14. Again, it's open because it's not equal to, and it's going to be all values less than here. Okay? And we have x is greater than -2, so at -2, we're going to also have another open circle here. And it's going to go here. And so this has to satisfy both of these. So what ends up happening for our interval notation is we're going to go from -2 to 14, both with parentheses. Okay, we use parentheses because these are open circles. We don't include them. Had they been greater than, less than, and equal to, then we would have used brackets here. Okay. So let's go ahead and have you guys give this a try. I want you to do the same thing here. I'm going to get you just a little started. So I don't want you guys to fall into this trap. Look at this -3 here at the beginning. To undo that -3, you want to add 3 to both sides. And don't forget that -6, absolute value of 4x minus 10 is less than -87 plus 3 is a -88. 4. I'm going to stop there. Okay, I want you to do the rest. Make sure that you isolate the absolute value, solve for the first case, then apply the KISS method, which is keep it switch switch to solve for the second case. And we'll see some more of these skills in a few slides in just a little bit, but let's go ahead and move on. All right, so for this one here, let's go ahead and read this. It says the machine is used to fill each of several bags with 16 ounces of sugar. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, the bag is rejected. Write this equation to find the heaviest and lightest bag the machine will approve. Okay, so here I've got some information. We want to first identify our central value and range. Our central value is typically what we want, or it's our middle term, right? It's our middle. So for this problem, let's go ahead and read this. It says the machine is used to fill several bags with 16 ounces of sugar. This is what we want. Okay, and our range value, okay, is like our plus or minus. And it says here 0.3 ounces more or less. 0.3. So we want to set this absolute value equation, and I'm getting this here from step number 2, which is the absolute value of x minus c is equal to r. Okay. When we solve this out here, we're going to substitute in for c, so it'd be minus 16 is equal to 0.3. And this is our equation for solving. Now I do want to take it a step further, and we do actually want to solve this. So we take our case, which is the absolute value of x minus 16 equals 0.3, and we can drop the absolute values. So we say x minus 16 equals 0.3. To solve this first case, we'd add 16 to both sides, and we get that x is equal to 16 plus 0.3 would be 16.3. And with all absolute value equations, we know that we're going to have two equations, right? So we go back to our original, our isolated absolute value, and we apply our KISS method. So we're going to keep what's inside the absolute value of x minus 16. We switch the equals, which just stays as equals, but then we switch this 0.3 and it becomes a negative 0.3. To solve, we would add 16 to both sides, and I get x is equal to, well, 16 minus 0.3 would be a 15.7. And these are our answers here. Okay, we have our positive solution, our negative solution, applying essentially the KISS method. All right. So let's go ahead and move on to yours. I want you guys to apply the exact same skills here. So make sure that you identify your central value and your range value. Use the equation, the absolute value of x minus c equals r. Get your equation, solve for the positive case, and solve for the negative case. If you have any questions, I will be walking around during class instruction for this. Best of luck. Let's go ahead and move on. So this question is interesting. Same skills. We're going to use the same KISS method for this. I went ahead and put detailed steps in here. But you got to be very careful what the question is asking. It's not asking us for the solutions. It wants to know what the sum of the solutions is. So again, with all absolute value equations, we know that we're going to get two solutions. And once we have our two solutions, we want to add those two. So let's go ahead and start off in the beginning. We have 2 times the absolute value of b minus 1 plus 2 equals 8. Step number 1 says to isolate the absolute value. So that 2 in the beginning, we want to get rid of that by dividing everything. But before we even do that, we look at this plus 2 afterwards. I know everybody's like, oh, let's just divide. No. Look what's being added. It's best to get rid of that before we start dividing. It essentially give you the same thing, but sometimes given specific problems, you might actually end up with fractions, and then you get whole numbers afterwards, but you just don't want to mess with those fractions. So let's get rid of that plus 2 by first subtracting 2 from both sides. And so we're left with 2 absolute value of b minus 1 equals 8 minus 2 is 6. All right, so we still don't have our isolated absolute value because of this 2. So we want to divide both sides by 2. Remember, the opposite operation of multiplication is division. These 2 simplify out, and we're left with the absolute value of b minus 1 equals 3. And I'm going to box this, not because it's our answer, but because this is our isolated absolute value. So we're going to start off with our first case, the absolute value of b minus 1 equals 3. And we can go ahead and drop the absolute values. So we have b minus 1 equals 3. If I want to get b by itself, I need to add 1 to both sides. And I get here that b equals 4. Okay, I'm going to box this. This is important to us. Not our answer, but it's important. We then go back to our isolated absolute value, which is the absolute value of b minus 1 equals 3. And then we're going to apply the KISS method, right? So we keep what's inside the absolute value, which is the b minus 1. We switch the equals, which stays the same, and we switch that 3 to a negative 3. Okay? And then we do the same thing. We solve. We're going to add 1 to both sides. And these simplify out. So I get b equals negative 3 plus 1 is a negative 2. So these are our solutions, not our answer, though. Remember, it says, what is the sum of the solutions? So our two answers are 4 and negative 2. So we'd have 4 plus, because the sum is plus, of negative 2. This is essentially just 4 minus 2, which equals 2. So you got to be very careful. We've seen this in the past in previous unit exams and mid-unit quizzes, where it's not just to solve. They give you an extra step and they want you to actually add or subtract or multiply whatever values you get. So be very careful here. And that's actually the same thing that I want you to do on this slide here. So you're going to go ahead and solve for your solutions using reverse operations and then the KISS method. You'll get 2 answers, and then with your 2 answers, you want to add them. You want to get the sum. If you have any questions, please don't hesitate to ask. Let's go ahead and move on. And so this is actually dealing with transformations, and it's an interesting question. It says to solve for the location of point P given the following transformations. So we look at point P here, and P is essentially some x and some y. We also know that this could be written as x and f of x. F of x was just another way of stating y. Well, this point here, and I'll write it again, is actually going to be negative 2 comma 2, right? Where negative 2, and I'm going to write this off here, x is equal to negative 2, and f of x is equal to 2. And I'm using f of x because you see here on the transformations, it's saying g of x is equal to negative 4 f of x plus 5. And so what's happening in all this? Well, it's a lot more confusing than it actually is. So what we need to solve for, okay, is what our new g of x is. And we do that by taking this, and we're going to say negative 4 times f of x. So what is f of x? We've already stated that that's 2 plus 5. Okay, so we're just looking for a new point. When x is negative 2, f of x is 2. But we want to know what g of x is. And so we're plugging in for that f of x value. We're then going to simplify this out. Negative 4 times 2 is negative 8 plus 5. So then g of x is equal to negative 8 plus 5, which is negative 3. So our point now is actually going to be negative 2, because x is negative 2, comma, negative 3. Our x didn't change, but our f of x then turned into g of x, just based off of the equation that they're asking us to go through. Nothing really changes much. You just need to be very, very careful. You're actually going to be doing the exact same idea on your practice question here, when g of x is now negative 3 times f of x plus 4. So your x, hint, hint, doesn't really change, okay? But what does change is your y value, essentially. You're going from f of x to g of x. So be very careful with that. And this actually concludes our Unit 2 review. We covered everything from solving absolute values to solving absolute value inequalities to observing some basic transformations. So please be sure that you take your time on this. Remember, I will be grading this the following day. So whatever you don't finish in class, you are expected to finish for homework. If you have later in the day you have any questions, please send me a message on Teams and I'll be more than happy to help you guys out. You'll have a great day, be great, and we'll see you all later.